This section was all about Azure Functions, a key component of Microsoft's serverless services. With functions, Azure manages the infrastructure for us, which lets us focus on writing the actual behavior, the code that we need to complete a task. The core concepts of functions are triggers and bindings. A trigger is what causes a function to run, like an HTTP request or a message that's being put on a queue. Bindings connect your function to other Azure services, either as input or output. In case a binding can't do what you want to do, you can also organize your code much like you would do when creating a typical ASP.NET Core API. If you know how to do that, you kinda know how to write a function. I would advise not to over-architect in this case though. A function is typically small and self-contained, and that doesn't call for the same type of architecture you'd need when creating an ASP.NET Core Web API project with hundreds of endpoints. Two types of Azure functions exist: regular and durable. Regular functions are for short-lived stateless tasks, while durable functions are for long-running stateful tasks. Durable functions are great for complex workflows that require state management and coordination between multiple functions. You learned how to create and deploy an Azure function. You can use Visual Studio or the Azure CLI for this. And once deployed, you can monitor and test your functions using Azure's built-in tools, like App Insights. Lastly, we touched upon securing your functions. You can set different authorization levels, such as anonymous, function, or admin, to control access. When you've got the opportunity, using managed identities to handle authentication between Azure services is the way to go. So all in all, Azure Functions provide a flexible, scalable, and cost-effective way to build and manage your applications in the cloud. They allow you to focus on writing code while Azure handles the infrastructure, making it easier to develop and deploy your applications. Azure Logic Apps are a tool for automating workflows and setting up integration processes between a variety of services, built with simplicity in mind. Very little code is required to create a Logic App. In this section you will learn all about it. I'll start with introducing Logic Apps. What are they? What are they for? And what do key concepts like workflows, triggers, actions, and connectors mean? Then we will implement an example Logic App. While doing that, you will learn how to test and debug them, and how to secure them. You will also learn how to integrate a Logic App with another Azure service, an Azure function from the previous section. Lastly, I'll compare Logic Apps with durable functions, as there's a bit of overlap between the scenarios they can solve. Let's dive in. For a lot of businesses, there's a growing need for integration of processes and services. Think about automating the sending of a mail to keep your team members informed when a new payroll data file is uploaded to a certain location, and at the same time start the service to process that data. Think about setting up a synchronization process between your custom API and CRM to ensure data consistency. Think about automating approval processes, like approving an expense by automatically routing the request through the appropriate managers, and so on. That's where Logic Apps come into play. They are a tool for automating workflows and setting up integration processes between a variety of services. It was built with simplicity in mind. The idea is that you should be able to create and run these Logic App workflows with only very little or even no code to write. Creating those is done on the portal with a visual designer. Logic Apps are considered to be part of Azure's serverless offering, so you get all the benefits of that, the option for consumption-based pricing, no infrastructure management, and automated scaling. Sounds interesting, right? Well, it is. In fact, it is one of the more popular Azure services, not at least thanks to the ease of use and flexibility they offer. The examples I described are quite simple, but you can design really complex business processes with Logic Apps easily. In fact, one of the clients I work for extensively uses Logic Apps for their business flows, including but not limited to incoming request transformations, integration with function apps and existing legacy web APIs, response transformation, enhancing error details and flowing them to the correct teams, and so on. The magic keywords are workflows, triggers, actions, and connectors. It starts with a workflow. That is essentially a list of operations, a list of things that define the work that needs to be done. It can be a task, a business process, or anything else really that you can define as a set of operations. A workflow always starts with a single trigger. Such a trigger is the first operation in a workflow. In a trigger, you define the criteria that have to be met for the subsequent operations to run. Typical triggers are an HTTP request that's sent, a mail that's received, a blob that's being added to blob storage, and so on. Another often used triggered operation is the recurrence trigger, which allows you to schedule your logic app run. And then there's one or more actions. Actions are the operations in your workflow that are not the triggered operation. So, workflow, triggers, and actions. But how do you connect other services to them, to the code or behavior you want to see executed? That is where connectors come into play. A connector is a type of operation used for integration. Through such a connector, you can integrate with Azure Functions, with blob storage, with app services, and so on. Connectors come in two types. Built-in connectors are, built into logic apps, which allows them to run natively and directly along with runtime. They are the fast option, and the examples I just gave, Azure Functions, blob storage, app services, all those connectors are examples of built-in connectors. Next to these, managed connectors exist. These are essentially pre-built proxies or wrappers for services and servers like Office 365, Salesforce, SQL Server, SAP, and so on. At the moment of recording, there's more than 1,000 different connectors available to choose from. Alright, that should give you an idea of what these logic apps are for and how they work. Let's see if we can come up with a demo scenario to build. In the updated destination images slice, which we implemented in the Getting Started course, we wrote code that put a message on a storage queue when an image blob was created or when an image blob was updated. With another HTTP request, one to API/process destination image changes. Those messages were read from the queue and handled. We could change this process by automating it further. We could create a logic app that monitors the blob storage for newly created or updated image blobs, and then triggers a process to generate those reports, for example. For the demo, I'm going to start with monitoring blob storage and triggering something using a logic app. Say, sending a mail to the team that's responsible for those reports, so they can get started with them. After that, we'll expand on this a bit, and we're going to simulate the process of generating the reports. I'm going to integrate with an Azure function to mimic this. Let's get going. Let's create our first logic app over on the portal. So I'm going to click Create a Resource, and let me look for Logic App. I'm going to check Azure Services Only here, and here it is, the Logic App service. Let's click Create. The first thing we need to choose here is the hosting plan. Just like with Azure Functions, this is quite important because this will define how your logic app scales and how costs are calculated. The first option here is the consumption plan. Automatic scaling, pay-as-you-go billing, a true, fully managed serverless approach. In this plan, a logic app can only have one workflow and resources are shared across tenants. The other two options here are not consumption-based. In other words, the pricing is not pay-as-you-go, but based on a pricing tier. With a workflow service plan, you do get more control over the runtime and performance settings, as resources are not shared. There is more built-in connectors, and you can also create your own connectors. With this plan, a single logic app can have multiple workflows. And then there's the App Service Environment v3 plan. It has the same features as the Workflow Service plan, plus the ability to fully isolate your logic apps and the ability to set up auto-scaling if needed. There's a few more differences and details, but the ones I just mentioned are the most important ones. There's a very convenient page over on Microsoft's documentation that can be used as a reference point to help you with deciding what's right for your use case. You can find it via the URI on screen. I'm going to go for the full-on serverless approach, the consumption plan. So let me select this and let's click select down here. Alright, I'm assuming the next page is mostly familiar. We need to choose our subscription and resource group. We're still working on travel inspiration related stuff, so I'm going to put that in the same resource group. I'm also immediately going to select West Europe as region, as that is where I am located. And let's then choose a name for our Logic app. As far as naming goes, I am going to stick to the naming principles we're used to by now. I start with the name of the department inside of the fictional company we're building this for. We are developers, so we are in the app dev department, application development. Then I add the resource type, or rather an abbreviation for it. The abbreviation for Logic app is Logic. Up next, the environment, dev, then the region, WE. And lastly, we need something that describes the workflow that we're going to build. Say process destination image changes. I'm going to leave everything else at its default, so no tags, review plus create. It's validating, and let's click create here. While that is going on, as you know by now, you can also fully create this app via the CLI. The command you're looking for is AZ Logic app and the subcommands related to it, like AZ Logic app create to create it. In the meantime, our Logic app was deployed. Let's go to the resource. There's not much to see here yet, but we can already see runs history, trigger history, metrics tables over here. So this does point towards quite extensive capabilities for inspecting and debugging Logic app runs. We'll get to that. Underneath the Development Tools menu item, we can find the Logic App Designer. This one is used to visually create our workflow. This is actually the default common way to create Logic App workflows. So creating those is not something you tend to do in code. It's something you visually design. That being said, a code view is available. If we scroll down, we can open the Workflow Settings blade. This blade allows configuration of this Logic app, albeit a little bit less than what we're used to with the other hosting options. An interesting one, security-wise, is the fact that you can set allowed inbound IP addresses. Like that, requests will only be allowed from a specific IP range, which adds an additional layer of security. Next to that, we find the typical blade you'd expect from an Azure resource: authorization and identity-related blades, and a set of monitoring blades like metrics and logs. I'll actually revisit quite a few of these during this section. And with that, it's time to create our first Logic app workflow.